Hello and welcome everybody to the Modern Web Podcast. I am your host, Rob Ocel, the VP of Innovation at This.Labs. Today we're going to be talking about secrets. We're going to be talking about configuration and environments with the wonderful co-creators of Varlock. Today we have Phil Miller and Theo Ephraim, who are the co-creators of Varlock. Welcome, guys. How are you doing?
Great. How are you doing?
Thanks so much for having us.
Doing wonderful. Listen, for people that maybe aren't familiar, you guys have been building up a lot of steam with this tool that you're using. Can you kind of help people understand, I guess, from a high level, what is Varlock? Like, what does it do for people?
So, basically we all use environment variables mostly, right? And they're used in different ways depending on the framework that you're using and, what language you're using. And a lot of the ways that we interact with them are through .env files. And while that kind of works in some cases, there's a lot of problems with sort of the status quo. And so, the sort of norm is you have a .env.example file, you copy paste it, you fill stuff in, you have secrets sitting there in plain text, it gets out of sync, you have validation logic somewhere else if you have it at all. It still takes a ton of custom glue code to wire all this stuff up. And really what we're trying to do is provide a universal toolkit to just make configuration, secrets management, .env files just a solved problem, and one that will work in all cases. It's very common that even in a monorepo, if you have a few different tools, you might have a different configuration system in each part of the monorepo. And it's like, why on every project do I need to either wire the stuff up myself, reinvent the wheel, connect all these things together? Why can't we just have one tool that does it and does it, in a much more ergonomic way than you would ever build yourself?
Yeah, listen, I mean, we just encountered this pain point ourselves. We're onboarding a couple new developers, and there's always that process, and they're onboarding when you're like, okay, you need your env file. Oh my goodness, it's been so long since I last edited mine.
Mm-hmm.
Some of the values are in one pass. Some of them you copy. Some of them you get from this website. Here, just use mine as an example and then change it from there, right? I feel like this is a universal pain point because sometimes we don't play in the env files as much as we might like to.
Totally. Yeah. And I was just going to say, it may not be your top of mind problem every day, right? But this is a universal problem that we encounter over and over again. It's like every time a new developer comes on the team, every time we add a new API key, a new service, every time we're setting up some kind of new CI or deployment platform, it just happens over and over again on every single project. And you're always, the beginning of the project, okay, how am I going to do it this time? All right, I'll deal with this later. And then eventually you have to deal with it. And, you end up, again, reinventing the wheel, copy pasting what you did on your last project. Why are we wasting our time with this?
Yeah, so we're just trying to get that stuff out of READMEs, out of Slack, put it in one place, put it in source control, make it very easy to reason about, and make it a source of joy instead of a source of frustration or fear, right?
Yeah, I mean, it's so funny, too, because I think with any great solution, sometimes once you've seen it, you're like, wow, this makes a lot of sense. I mean, can you guys explain a little bit about how it is that you get secrets out of being in plain text? In other words, how we can make it so that, I don't have to tell somebody, oh, yeah, you go to this website or one pass and you grab a few things out of there, and then you go to this account and you go grab the signing secret out of that thing, and then you go over here and you do that. Mm-hmm. How have you guys made it so that people don't have to worry about where to go and find all that stuff themselves?
Yeah, I mean, if we actually go back one step and just think about sort of aside from secrets in plain text, just how do we make this problem better, right? And I think the first step is that when you have a .env.example file, the idea is that you copy paste it, right? And when you copy paste it, half of the items are placeholders, half of the items are actual values that are meant to be used. Some of them say, hey, go ask Bob for this. There's some comments, but you don't really want to put too many comments because as this file gets longer and longer, when you copy paste it, it starts to feel totally overwhelming, right? So the first sort of step is how can we just simplify this? And the answer is, instead of having this copy paste, two file problem, let's make the example file into a schema. And that's something that is a living document that is actually part of the loading process. And that means that it never gets out of sync, right? And as soon as you do that, you now have a very clear place to say, okay, this is an actual value that's going to get used. This is just an example. It makes sense to start putting more and more documentation in there because, you're not copy pasting it anymore. And the more you put in, the more valuable this thing gets. The second now part of that around secrets and everything is that once you have this kind of more powerful system, you want to be able to do other things with it. And what we've introduced is this function call syntax. So, some of y'all out there may have used 1Password's like OP-CLI to inject stuff. And basically it'll look at all the values. If it sees something that looks like a 1Password path, it will swap it in, right? And that's great. But why not make a universal solution that can just take a function and do whatever? If that's swapping in something from 1Password, great. If it's composing other values together, great. If it's an if statement or whatever, right? So we have this function call syntax that lets you call out to any external CLI. Could be 1Password, could be anything. And then we've recently introduced a plugin system so that you can actually register a new plugin that will install new functions. So the first one is for 1Password. And then that introduces a new OP function. So instead of just saying, hey, this is a string that looks like instructions to go do this thing, it is explicitly instruction to go do that thing. And so you can imagine, aside from 1Password, you could imagine plugins that would fetch secrets from a bunch of different backends, AWS, all the cloud providers, or in physical or whatever. You could also imagine a plugin that just decrypt something using a key that's on your machine, or the plugin I'm working on right now is to use your native kind of key ring. So go fetch it from your keychain and in a sort of cross-platform way. That's a great first solution just for keeping your local stuff out of plain text. It's not as great as it could be because for a bunch of reasons it doesn't use biometric unlock, and it's hard to share with other users, but at least it's something. It's a good first step.
Yeah. And because of that sort of multi-platform or, unopinionated approach, you can have 1Password secrets locally or use something else in pre-prod or use something else in production. And you can see that in the schema. So you can understand where things are coming from, even if you don't have access to them. So, in your production file, you could say, load it from secrets manager, or in pre-prod, just load it from the environment itself. And that's all very obvious.
We'll be back to the episode in a second, but first, I'd like to acknowledge the team behind the channel, This.Labs. We're seeing 3x to 5x productivity improvements with our teams and clients using tools like Cursor, Claude Code, and GitHub Copilot. We help teams adopt these technologies and get max value out of them through strategic partnerships, trainings, and other software engineering services. Check us out at ai.this.co. Thanks, now back to the video.
Yeah, I want to talk about environments a little bit more in a bit. Not the env files, but different environments piece. Yeah. But I want to stick on the schema a little bit more because I think I want to whet people's imaginations with what they can do with this. Because I think when we think schemas, immediately you're just like, okay, it's a string, it's a number, it's a key, okay, whatever. But what are some of the other things that maybe people aren't thinking of off the top of their head that they can do with schemas, specifically with environment files, that they might not otherwise think of?
Yeah, I think the first and foremost, understanding what is and isn't sensitive. So that, now you can just mark something as sensitive. We know it's a secret or something resembling a secret. And if you think about it historically, or even maybe today for you guys, you've got a bunch of not secret config that lives in const files or, scattered throughout your code base. And then you've got a bunch of secret stuff that lives in a .env file or, wherever else you're getting those secrets from. But why, say you're doing a Stripe integration, you have a public key and a private key. Why are those in two different places? So, it allows you to put like group things beside each other where they should be. And because we understand what is sensitive and what isn't sensitive, we can handle that properly on the application side.
Yeah, and one thing it's important because we haven't actually shown anything, just audio. The way that all of this schema stuff works, in a lot of other tools that have been thinking about this problem, it's like, okay, here's the schema file, and now here's the values file, right? In our system, we've sort of unified this, kind of similar to QLang, if you're familiar. But the idea is that you use decorator style comments. So above an individual item, you would have what looks like a normal comment in a .env file, so a hash, hash symbol, and then an at required, at sensitive, at type equals URL, at type equals string, and then it takes options, starts with equals whatever, right? So there's sort of all these utilities where you can add a ton of validation without having to, write all this custom stuff. You can add docs, like multiple docs links and a nice description, and all of that stuff gets funneled into a generated TypeScript types file. So you have at the end of the day, this really nice type safety without doing some crazy voodoo to extract it with Zod and these insane types, right? It's actually just a normal TypeScript file with a big comment block. It'll have multiple links to the documentation. It even has a little SVG icon in there. It looks, really slick. And it's not possible if you're trying to do it another way. And it encourages you, like the more work you put into this schema, the bigger the payoff is for your entire team.
Did I see right too that there's like even little things like coercion and stuff like that when you actually execute the schemas? So you could say that something is an integer, for example, but whatever value you type in, if it was a float or whatever, it would just shrink it down and coerce it into an integer.
Exactly. Yeah. So
I'm not sure if you want to do that much, but I just love that idea though, that you can, you don't have to worry about doing the conversions yourself necessarily, if depending, like you were saying earlier, because we can source this data from many places.
A good example is like a port number, right? So there's a type that's a port, and it will coerce it to an integer, and it will make sure it's within the normal port range and all of that. And it's not that hard, but it often in a code base, when I go and swap in Varlock, it's like I remove from 4 different places conversion to a number, and all, it's like, why is this stuff happening here? Like, let me just put it in one place.
Yeah. And think about all that sort of code that's just like, if this, then this, or like casting to Boolean. Like one of the things we often see Boolean is all of that like node env check all over the code base, where it's like, if not production, then use dev URL. Now that can be completely codified in your schema.
That's a really important point, which is that because of all of the pain points of using .env and this copy paste and getting out of sync and blocking your teammates if they don't have the new n variable, I think we all just avoid using them, right? It's like you just don't want to touch them because you don't want to mess anyone else's workflow up. But once you have this really nice toolkit where it's actually helping you, you're suddenly like moving more and more stuff into your end file and into environment variables, right? And what that lets you do is, like Phil was saying, remove all those like what app or what env am I in, right? And instead, everything can have its own environment variable that toggles it in very fine individual things. You could still set sort of what the default is based on the environment, but you're no longer having all that code scattered throughout your code base.
Yeah, I mean, I like that idea that some of the things that you're doing are doing double work for you. This idea that you're schemifying it, which is, yes, it's helping you as you're filling it out, but it's also helping Varlock put the values in there in the correct formats. It's also helping you understand inside of your TypeScript while you're working with your code, what those types are and having that kind of type safety right away. But you get some of that runtime safety as well. Because I know like we have this where some of our environment variables, we're checking them for lengths, we're checking them for structure to make sure that we're not running off and, you gave us the wrong type of thing and now we're doing the wrong information. So, I like that idea that it can suck all those things into just one activity versus having to do it in multiple places to capture this. Like you said, using Zod and then also having logic that checks that these things are correct, et cetera, et cetera, et cetera.
Single source of truth, right? And having it happen no matter where you are. Am I booting up some external script? Am I booting up, my own little side script? Am I booting up my application? It's going to give me a nice error message right away with clear, hey, this is wrong because this is not passing validation, instead of getting some weird runtime explosion because something doesn't look quite right.
Yeah, think about like how many times you've spent all this time like creating a new feature. You've tested it in staging. Everything works. You deploy it to production. You're about to celebrate on Slack, and then it's not working because you didn't log into Vercel and paste in the new API key. We can prevent like that entire class of errors because we can tell you that it wasn't there in the first place before you deploy it, or potentially even earlier because you can validate the shape of any environment as long as you have access to the things you need for that environment.
This is getting into the weeds a little bit, but I was curious to go through this a little bit. Like, talk a little bit about what these different sort of stages of execution are. So I know with like Varlock, there's this idea of a load and there's an idea of like running. So it's like, what are these different operations that can be done so that people can kind of understand how best to use the tool? I know the one that really surprised me in a cool way was this idea that you don't even have to integrate the the environment variables like a .env style into your code itself, but that like it has a way to run ahead of time, so it sets all the variables up for you before you execute something. Like, can you help people understand these different, like, I guess, high level functionalities or invocation ways that Varlock has?
Yeah, I mean, basically, there's a load command, and when you just run that, it will, first it looks in the current folder, looks for a schema file, and it will look for other files as well, .env.local, .env.development, .env.development.local. All the sort of .env flow is the name of a library that sort of popularized this. So it'll load all of those. It will follow. There's also an import syntax, so it would follow any imports. It will, load everything up. It will combine all of the data, like, values can sort of override each other. Decorators can override each other too. So it will sort of combine all of that into a big schema, and then it will go and resolve it. And the load command will give you a nicely formatted output with, everything that's sensitive is redacted. It'll say, here's all the values. And if it fails, it'll say, hey, these are the ones that are failing. Here's why. That's actually really nice in CI to add as an additional step, because now in your logs, you have a step that shows you, hey, here's what the environment was when this happened, right? Which is a huge pain to debug normally, right?
That makes a lot of sense, because my first thought was that load was the thing that was like, say if I had one pass, that was the thing that was going out and pulling the one pass values. And I guess you're saying it does, but for the purposes of checking to make sure that process would happen correctly and everything schematically lines up.
Load also has a flag, so you can say what format it's in. The default is this nice, pretty printed thing, but it also can spit it out in JSON and
that makes sense.
or in .env kind of style. And that's actually what's used under the hood of like a bunch of our integrations. So for example, there's a Vite plugin that will, go and load it and then inject everything properly. And under the hood, it's just calling out to Varlock CLI to load. And one thing that's nice there is that there's sort of this clean separation between the Varlock CLI running that might be going and fetching stuff and whatever it has to do, right? And your application code. It's sort of a clean split. And then there's this Varlock run command, which does all the same stuff. Go load everything, go resolve everything, run the validation. If it fails, show an error message. But if we're passing, it will now just inject those environment variables into whatever process you're about to run. So or whatever command you pass to it. So that's the same as 1Password has a thing, op run, a lot of these sort of environment loaders will have this sort of run command. And that's, even if you have a nicely integrated, Vite app or something, say you still want to, run a Prisma migration or whatever, run some external script and feed something into it. You can run Varlock run -- my script or other tool, right? If that tool doesn't give you a way to pass it in without environment variables.
Yeah, I find that super useful. Like, the first step on all these tutorials to use an MCP server is go get this API key and stick it on plain text in your machine. So I'll put those in 1Password, and then I'll do Varlock run Gemini CLI or Varlock run Claude, and then it's passing those in securely so they're never sitting on the disk.
Yeah, so important these days, right? I mean, like I guess we sort of are talking about it now. Like, talk about what the potential is with this, with the fact of how many AI tools we're using nowadays. I mean, we're talking about using it in the software we're writing, and that's totally valid. But I feel like with so many things, the MCP servers, agents, etc., like, it is still a mess as people are trying to figure out how to do auth the right way and not own themselves with very important credentials. So talk a little bit about like what, I guess, the joys you've found using this tool as you've been using AI products or, helping people set up AI stuff.
Yeah. So, I mean, there's two sides to it, right? There's, I think, the security side of it, that we need to get these things out of plain text because AI tools, and we'll use that as an umbrella term for now, are reading these files, even if they say they're not reading this. I don't know if you've seen these tweets where it ignores the .env file and then it just runs a CLI command to cat the file and then read the output. So even the AI tools are circumventing their own guardrails right now and reading these files. So we need to make sure there's nothing sensitive in them. I think we've done a pretty good job of, fixing that problem. And then I think the other side of it is just because of this schemified solution, there's more structure around writing the schema itself so that the AI tools can reason about that and understand how to write it. So, one of the things I'll do is say I'm doing an integration. I'll say, here, write the integration, and it knows based on the rules I've set how to write that schema. And if the schema fails validation, it knows to run Varlock load, see what's missing, and then help it sort of self-remediate. So I think that's pretty powerful. And then also just securing all of those one-off CLI commands, one-off tools that you're constantly trying, because we're constantly spinning up new repos and running new tools. So we need just like the base set of security to be really good.
Yeah, there's one other thing that we didn't really get into, but because in our schema we know exactly which items are sensitive, we can do some pretty cool stuff with that. And so two features we have implemented. There's a third that we'll probably do at some point, but one is log redaction. So we patch global console methods. So if you try to log anything sensitive, or it just gets logged, however it got logged, it will redact that value from the output. The other is patching global response and server response methods so that if your server is about to return a secret in the outgoing response, it will just stop it. And so with MCP servers, where you might be needing to feed in these sensitive keys so that it can talk to some external process, you can be 100% sure that it is not going to accidentally leak the key in a response, which, probably not that, it's not like this is happening every day on tons of these things, but just that extra peace of mind, I think, is super valuable.
Well, especially as these agents get more potent. I mean, I think that's the thing that everybody's learning all the time is it's all fun and games until you give the agent just a little too much power. And it's not that it's doing anything malicious. It's just simply that sometimes it just isn't aware what it's doing, and has done anything from deleting the database to giving people crazy elevation of privileges, vector attacks. And so I think, any way that we can add in, like you guys have been saying, very predictable, very, schematically defined, we elect to do it type of protections to help keep the AI on the right guardrails. I mean, these are the types of things we're going to need moving forward. I think are very potent when combined with these tools.
Yeah, I think also all of the AI assistants or the IDEs, they were slurping up secrets left and right. So everyone was, and when people realized it, they started, obviously yelling about it. And they all sort of went with the nuclear option, which is just like, we're going to hard code, never read a .env file. Anything that's .env, anything, just don't touch it, right? Great. But now when you're coding and you actually need it to add a new item or, interact with the env in some way, it's very awkward. And it tries to use these workarounds to get to it. So by introducing this schema that is meant to be checked in, or actually several files potentially that are meant to be checked in, you're now making it safe for the AI to interact with it, and which I think is just much more natural and is part of your coding process.
I'm sure most people, or a lot of people's projects, they have their .env .example, and then they have their .env .production and .staging and whatever different environments. How are you all handling that? Do you end up with schema files for each of the individual environments, or what are some of the things that people can do just so that they understand how you guys can support stuff like that?
Yeah, the idea is that you have a single schema, and by default, it'll just read that schema. But there's a thing called root decorators. So each item can have decorators, and then there's root decorators that live at the top that can sort of affect the whole loading process. So rather than, a lot of these other tools that do this .env loading will look at Node.env and decide, okay, is it, based on Node.env, it'll load certain files, or based on, am I running a build command or not, or whatever, right? With ours, it's a lot more explicit. So you will add a new item in the schema. We recommend to not use Node.env. We recommend introducing a new one called app-env, or, whatever you want. And then there's a root decorator that says, hey, the current environment is going to live in this app-env thing. And that app-env, you can add a type to. That'll be an enum, so you know exactly what the different things are. And then it knows, hey, that is the name, that's the current environment. I'm in development or prod or preview or whatever you want to call it. It's up to you, right? Based on that, it will automatically look for a .env. Development or dev or whatever you called it, and a .env.dev.local file. So that's one way of doing things. Is you can have that. You can break things up into multiple files. You can have those files. Some of them would be checked in again. Some of them would be .local if you're just kind of running things locally and you don't want to check those in. But there's also this whole function call thing where you can compose things however you want. So, for example, you could have a value in the schema that says, hey, if the current env is production, then the value is this. Otherwise, it's this, right? You can sort of compose things together in one file or break it up. Whichever makes sense. Kind of depends on your project, the complexity. We sort of just want to provide the toolkit and let you do whatever you want.
Yeah, the thing I like about that is because, I'm sure our project and our team isn't different than a lot of people's, but you end up having this complexity of saying, oh, well, the actual prod servers are going to pull their stuff out of AWS Secrets Manager, but in local, I'm going to want some of it in one pass, and then my GitHub Actions, when they're running on my PRs, are pulling it from a different source, and Vercel's getting it from a different source, and it really becomes a bit of a nightmare, like you were saying, is when somebody pushes a new value, and you have to remember, where all do I have to put this value, and when do I have to put it in? Is it before the build? Is it after the build? This kind of thing. So I love that idea that we could reduce this maybe all down to one schema file that each environment then would know to execute in the correct way. Like that seems very exciting, I guess, as a future, even if it's not 100% here. But that is like making me very excited on how much less I'm going to have to maintain.
Sorry, go ahead. I was just going to say, like, it's an incremental path to adoption too, right? So like if you've got all these values stored in, the UI on Vercel or, in Secrets Manager, all that last value is the one that will override all of them when it loads. So you can add a schema and validate the contents of the environment as it exists, or you can eventually move them into these functions as Theo touched on.
Yeah, I mean, you have the validation right away, so you know that things are correct, and then you can slowly remove this. The industry term is called secret sprawl, right? It's like I've set these things in a whole bunch of places. Not good for security, also just for cognitive load, right? Where things living. So you can sort of start, after you first just have the validation, you can start pulling it back and centralizing as much of this config as makes sense. And usually, what that could look like at the end of sort of this implementation is, say you're storing everything in one password, then on Vercel or on GitHub or wherever things are running, you would inject just the one secret, which might be a one password service account token, right? That then opens up the ability to load all the rest according to this declarative schema and instructions.
I'm curious where you guys see like the general users of this tool going. I mean, the way that I'm thinking about it and the way that we've been talking about it internally is this idea that, the widespread adoption of AI coding agents and vibe coding generally has created a situation where, like, when we set up a template for how to deploy a new project, we want to sort of set the level of it for where, like, the most junior member of the team could deploy a new project and maintain it reasonably, at their level of sophistication. And I think, with AI, that's going to be a huge thing too. Again, just for how much software is going to be built on top of just whether the agents do it. I know like larger teams and enterprises are going to have people whose whole role is dedicated to maintain these environments, these schema files, etc. But I guess, have you guys looked ahead? Like, where do you think, and where are you guys projecting, is the types of people who will be managing these things? Are you building it towards that future of just sort of more vibe coders in general getting into this space? Or how do you guys see your sort of target audience evolving over the next few years?
Yeah, I mean, I do think there's kind of a dual purpose here, right? Like we want to, like I've said several times, we want to get this stuff out of plain text. We want to help everyone who's using secrets today. So there's that, individual vibe coder use case, and that doesn't go away, right? It needs to work for them, but it does also need to work for these more complex use cases where you've got a mono repo that's maybe polyglot with multiple services, and you've got maybe some complex inheritance of that configuration. That is the core use case we've always kind of set out to solve, but we're approaching that through the lens of simplicity, I think, and that's what's largely brought a lot of people to us recently.
Yeah, I mean, I think we really from the beginning have wanted to build a tool that makes sense for everyone and not just for, oh, I'm in this big enterprise situation with all these very sensitive secrets and like now it makes sense to go and implement this thing and, pay a bunch of money, right, to set this up. Like we want something that makes sense to implement from day one, even on your own tiny project, but really shines with, a larger team and more complexity.
Yeah, it's a tough sweet spot to hit, right? But that's that goal of that's what developer experience, especially in this kind of industry, is. You want that low activation energy, you want that easy to sort of learn piece, but you want that impossible to master, or that idea that you can. Hopefully, the tool is. You never get to the point where you're like, well, this tool just isn't enough for me anymore. I need a much more sophisticated solution that like sort of opt into complexity. That's kind of the situation that you guys are setting up.
Yeah, and I think with the plugin architecture, like, the sky's kind of the limit in terms of the integrations there, especially as that matures. So, you can picture like any provider under the sun, as long as they have an SDK or a CLI that we can use, we can integrate with that. And then obviously, like, once you go into that enterprise use case, like things like, compliance and audit trails and all that stuff, we know we need to make their lives better too. And we have all this metadata, so I think it will make it better.
Yeah. And I mean, just looking towards the future, we really want this to become a standard, right? This should just be part of every template repo that you pull down. Every developer tool out there, when you go and pull down their instructions or their template, it's like, okay, first step, copy the env example, fill this in, right? Like, it should just be there. The schema is there. It'll yell at you if the thing that's required is missing, right? And like, you can even imagine every Docker container having a schema and Docker itself just running this validation as part of the booting process, right? And because you have that schema data, like now you could present all of that information about the environment variables in a unified, clean way, rather than having to look through the README of every Docker container going, okay, like what are the options here? What's going on? It really just should be a standard.
Yeah. And like, if you think about that sort of like onboarding story for a lot of these cloud hosting providers as well, like one of the first things you do is like set up those environment variables. Or I don't know if you've ever clicked that like deploy on Netlify button. If they set up their netlify.toml file properly, the first thing it's going to do is prompt you for environment variables. So imagine if there was a standard way to represent that, right?
You guys are sort of hinting around with the piece that I wanted to get to sort of near the end here, which is to tell us a little bit about this effort to standardize this. I think we've all sort of talked about or seen the sort of XKCD thing about the 50 competing standards, and we certainly don't want to end up in a situation where like, okay, that's .m files with these guys, but then there's going to be 14 different versions of this in the future. I mean, we already deal with this with the JS docs situation in TypeScript, et cetera, et cetera. It's all over the place, right? So tell us a little bit about the efforts that you guys are contributing to help be a part of the standardization of this.
Yeah, so I mean, there's a reason it's built on top of .env files. We know people are already using. There's a reason it's in comments, because we don't want to break the sort of standard as it is today. And we created an open spec that underpins all of this called env-spec. So anyone can adopt that syntax, and we hope that they do. But that needs to be an open standard, right? And that's why we started with that, and why we're starting with this as sort of the next step on top of that. Like, you can benefit from having an env schema file if you don't use Varlock, right? It's documentation, it's readable, it makes it more easy to reason about the contents of the environment. Obviously, there's some value add with the tooling, but there's nothing stopping, any cloud provider from adopting that spec as well and doing a bit of validation.
Yeah, I mean, you could certainly imagine someone else adopting the spec and implementing, the at required, at sensitive, basic types, and sort of leaving it at that. Ideally, the tool is more full featured, and that's what we've built. But just opening up the door for this, like, how can we help everyone express this schema information in a way that feels familiar, and in a way that starts to encourage us to not do this copy paste dance with env examples.
Yeah, exactly. And I just think, especially again, where we're going with the widespread adoption of AI, I just think standards become even more important. I mean, I think that's why MCP took off, in part why it took off so strongly, is just the world and the ecosystem just needed kind of one thing or one smaller set of things to sort of rally around and unify on. And so, I think not only will that standard, like you guys said, help people not feel like they're locked into what you guys are doing or that they're disconnected from what other vendors and other people might be doing, but again, it feeds back into being able to use AI to help maybe develop these env files and to refactor them and to make improvements to them, because this is going to be a standard that they will understand more holistically rather than it being so idiomatic to just this one tool.
Yeah, I mean, I'd love it if Claude just said, "Hey, it looks like you need these environment variables. Here's how you can get them," right?
Yeah, I mean, it's, I'll be the first to admit that like .env files and the sort of .env syntax and everything is not the best way to do this, right? Like it's very limited and sort of awkward. Like the first version of this that we built was this big TypeScript thing, and you have way more it's way more expressive. You have a whole language, right? But the reason why we sort of backed off of that and put it into .env is because that's where people already are, and that's what's familiar, and that's what makes sense in a in a polyglot world, right? This feels like a tool that you could use with every project rather than, oh, it's a JavaScript project, so I'll use it, but I'm not going to use it on this Go project, right? And like one thing I didn't mention about the type generation is that while we don't do it yet, because we have this type generation step and it's decoupled from the application code, we can generate types for any language, right? Any language that would support it. So soon we will have sort of deeper language support for those other languages.
Oh yeah, I mean that's a good point. I guess near the end here, like so JavaScript is sort of the obvious one. We talked about Node and all these different pieces. Like, can you give people a sense of, I guess, of the breadth of where they can use it now, and maybe the breadth of where you would like to use it? So, can they use it? I think we've talked about Vercel. Can they do it in kind of any of these backends, et cetera, et cetera? Like, are there other languages that you already support or that you're hoping to support soon?
Yeah, any language will work via Varlock run. So it'll do that, resolution and then pass it into the process. So any, language where you've got a sort of dev command or a boot up command, you're good, which I think is probably most languages. Obviously, like there's a deeper integration on the JavaScript side. We didn't really touch on the application framework integrations, which is how we do the, security guardrails features. So, JavaScript is the place we know. So that's where it's deepest first. But the polyglot story is there. And like Theo said, we're just going to deepen that as we move along.
Yeah, I mean, a lot of things don't need a special integration, but we have a Vite plugin, a Next.js plugin, a Astro plugin. A bunch of things use Vite under the hood, so that Vite one does a lot. There's some little instructions for certain things like Cloudflare workers, but in general, it works with Bun. It works. Somebody just mentioned Nest.js last night. I said, oh, let me give it a shot, and it works. Right? It's pretty universal, and we hope to expand that language support for other languages pretty soon. The sort of steps there would be support type generation if the language has types, add a sort of helper library that just helps load things, and add potentially some extra security guardrails like we do in JavaScript, if it's possible.
Yeah, and sometimes they have their settings in different files. So anytime you need, like the app setting stuff, anytime you need a .NET beta testers, you let us know. We'll be ready to let you know how it works.
Great.
All right. Well, as we wrap up, can you let people know where they can find you and the Varlock team online in case they're curious about the things that we've been talking about and they want to give it a try or reach out with feedback?
Yeah, definitely go to varlock.dev, varlock.dev. Click that star and star us on GitHub. And then, the company itself, dmno.io. That's sort of our corporate umbrella. And you can find us on X. So that's what it's called these days. Varlock Dev, all one word. And on Blue Sky at varlock.dev, because they have nice domain-based account registration.
You can also run in a JavaScript repo. You can do npx varlock init, and it will look at your existing env files and sort of do its best guess at spitting out a schema for you, marking things as sensitive and things like that as much as it can, and it'll kind of tell you what to do next. That onboarding is hopefully going to get better and better as we add to it, but that's a good way to just test it out.
And there's Homebrew standalone CLI, and you can install that, just via curl as well.
Wonderful. I love it. I mean, I love the focus on DX. I love the ability to just make it very easy to get in through the front door. I think that's always the toughest part, right? Is just get that first execution, that first experience with the app, and then people get hooked in it a little bit more, a little bit more, a little bit more to it.
Yeah.
Awesome. Well, thanks so much, everybody, for listening to this episode of the Modern Web Podcast. Thanks to our guests, Phil and Theo. As always, we say the conversation does not stop here. You can find me online at RoboCell. You can find the podcast online at modern.web. As for all the things that you just heard, we'll make sure the links are in the show notes so you don't have to rewind and re-listen to it all. It should all be clickable down below. But yes, we all hope to see you all next time. As we close out, we would just like to thank today's sponsor, This.Labs, one more time, who would like me to remind you that This. Is dedicated to guiding companies through their modernization and AI transformation journeys. This.Labs is a tech consultancy that specializes in amplifying your technical capabilities, whether it's expanding your dev team with seasoned professionals or streamlining your project's journey from ideation to deployment. We work with clients like Google, Microsoft, PayPal, and more. Check us out at this.co. One more time, that's THISDOT.co. All right. See you all next time, everybody.
Thank you so much.
Bye-bye.